So again, I have to ask you, forgive me, I'm not able to transfer these very well over, but you get the idea here. This one is for question 16, given the isotopic notation for tellurium-130. So that's this symbol, isotopic notation over here. Now notice this is now charged. It's a charged species. It has a 2 minus. The 52 tells us how many protons. So there are 52 plus charges. If it were neutral, there must be 52 electrons. It's not. There are 2 more electrons than protons, so it must be 54 is the answer we're looking for here. 2 more negatively charged particles than positively charged particles give rise to a -2 total charge. Okay, for question 17, one of the things I asked you to know is what is the way an element on the periodic table exists under normal conditions in nature, under standard temperature and pressure. And the default that I asked you, I told you the default is just assume they're all atoms. But there's exceptions, and those are the diatomics. And that's what we're talking about, just an atom versus a diatom, where there's essentially 2 atoms that are connected. And to do that, we want to look at the periodic table. Let me see if I can pull that up for you. So that's here. And the way to remember this, okay, remember they're all by default atoms, but then we come to, in the periodic table, the most abundant gas that we breathe in the air. It's not oxygen, it's nitrogen. About 78% of what we breathe is nitrogen. So start there, and then what you do is go nitrogen, oxygen to fluorine, and then you turn and go down. And these are diatoms. So nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Start at nitrogen, the most abundant atom in the atmosphere, or element, and then you turn at fluorine and go down. And those are the diatoms, with one other exception, and that's hydrogen up in the upper left-hand corner, H. Those are all the diatoms. So which one does not exist? Well, nitrogen does, fluorine does, hydrogen does, helium does not. Helium, we'll go back and look, it is located in what are called the noble gases. It's a gas, but it's not a diatom. We switch at fluorine and go down. All these gases over here, helium, neon, argon, krypton, xenon, are atomic. That brings us to question 18. So a sample of propane. So let's just sketch this out here. A sample of propane. So I've got a pile. That is propane. And my problem tells me it's 25 grams. And it is burned in oxygen. So I've got a pile of oxygen. That is oxygen. And it tells me that's 86 grams. And I jump over the arrows. That means burned. A reaction happens. And it tells me that CO2 is formed. So on this side, I got a pile of CO2, and it is 78 grams. And also, I get a pile of water, H2O. And the question is, how many grams is this pile? Well, remember, this is a question really asking you, do you understand conservation of mass? I start out with 25 plus 86 grams over here. I have to end up with 25 plus 86 grams over here. The mass doesn't disappear. So I'm just simply going to take the total amount of mass on the left, subtract the 78, and that will tell me how much is left. So 25 plus 86 is 111. That's what I start with. I know I end up with 78, so I subtract that off. And that leaves me with 33 grams unaccounted for. That must be in this water. So conservation of mass tells me what I start with on the left must end up on the right, and so it's a simple subtraction.